Yes, we are going to discuss chapter 11, section 7. Section 7 deals with a strategy for testing the convergence of an infinite series. That is, there are several methods, and when you get a problem to check whether a series is convergent or divergent, you have to choose the most appropriate method or the technique. And here are the few techniques or few easy ways. One, if limit n approaches infinity an is not equal to 0, then sigma n varies from 1 to infinity an is divergent. So see whether the limit is not equal to 0. If it is not equal to 0, the series is divergent, it is not convergent. But if this is equal to 0, it may or may not be convergent. We are not sure. But if it is not equal to 0, then series is divergent. That is the first technique. If n to the power of p is in the denominator, that's a part of the denominator, then try the comparison test or the limit comparison test and use the p-test. P-test is sigma 1 to infinity 1 over n to the p is convergent if p is greater than 1 and divergent if p is less than or equal to 1. Third method is an is equal to a r to the n or a r to the n minus 1, where a and r are constants. Then use the geometric series formula. Sigma n varies from 1 to infinity. A r to the n minus 1 is equal to a divided by 1 minus r. So that is the geometric series. But there is a condition here. The condition is here. R must be between -1 and +1. R is the common ratio. That common ratio must be less than 1 and greater than or equal to -1. Then the answer is A divided by 1 minus R. 4. Sigma -1 to the power of n minus 1 bn. This is an alternating series. It converges if limit n approaches infinity, bn is equal to 0 and bn plus 1 is less than bn. That is, it must be a decreasing sequence. Or f prime x is negative, that means decreasing function where f of n is equal to bn. 5. Sigma bn to the power of n. If there is an exponent n, then you may try the root test, which is limit n approaches infinity, an to the power of 1 over n. If that limit is less than 1, it is convergent. If an has n factorial in the denominator, then try the ratio test. Ratio test is, we will see that ratio test later. Limit n approaches infinity, and absolute value of an plus 1 over an is less than 1, convergent, is greater than or equal to 1, divergent. I mean, greater than 1, divergent, equal to 1, no conclusion. Okay, 7. If an is equal to fn, where fx is continuous decreasing differentiable function of x, then try the integral test. Sigma n varies from 1 to infinity. An is convergent if integral 1 to infinity fx dx is convergent. 8. If sine n theta or cos n theta is present, then you may try the comparison test because sine theta is less than or equal to 1. Cos theta also is less than or equal to 1. So we start doing problems now. This is question number 2 from the textbook. Sigma n varies from 1 to infinity. I did not write that. It is assumed. N varies from 1 to infinity, n minus 1 over n cubed plus 1. you have to check whether this series is convergent. You see, observe that in the denominator there is an n cube. So let us try the limit comparison test. And in order to get Bn out, An is n minus 1 over n cubed plus 1. And in order to get Bn, you discard all the non-dominating terms. So when you discard the non-dominating terms, that they are negative 1 in the top and plus 1 in the bottom, you get n over n cubed, which is 1 over n squared. So that is your Bn. So this is the general strategy. Now you calculate An over Bn, that is n minus 1 over n cubed plus 1 divided by 1 over n squared, that is equal to n minus 1 over n cubed plus 1 times n square over 1, because division by a fraction is the multiplication by the reciprocal, and distribute n cube, n square. So it becomes n cubed minus n square divided by n cubed plus 1. Now you find the limit. So limit n approaches infinity, An over Bn is equal to limit n approaches infinity, n cubed minus n square over n cubed plus 1. Divide numerator and denominator by n cubed. You get, that is the same as limit n approaches infinity, n cubed over n cubed, that is 1. So it is 1 minus 1 over n divided by 1 plus 1 over n cubed. And when n is infinity, it becomes 1 minus 1 over infinity, which is 0. So it becomes 1 minus 0 over 1 plus 0, which is 1. And that is a finite number. Therefore, sigma Bn is convergent because of the p-test. 1 over n square, p is 2, greater than 1. So sigma Bn is convergent. Therefore, sigma An converges. So this is the limit comparison test. We have seen this in one of the earlier sections. So that was question number 2. Number 4. This is an alternating series. Sigma 1 to infinity negative 1 to the power of n times n square minus 1 over n square plus 1. So Bn is n square minus 1 over n square plus 1. Therefore, limit n approaches infinity, Bn is equal to limit n approaches infinity, n square minus 1 over n square plus 1. That is limit n approaches infinity, 1 minus 1 over n square divided by 1 plus 1 over n square by dividing all the 4 terms by n square. When n is infinity, 1 minus 1 over infinity square, that is 1 minus 0 over 1 plus 0, which is equal to 1, not equal to 0. If the limit of the nth term is not equal to 0, the series is not convergent. So sigma An is not convergent. An means the whole thing, including the negative 1. Bn is obtained by discarding the negative 1 to the power of n. So limit of the nth term is not equal to 0. Therefore, it is divergent. Number 6. Sigma n varies from 1 to infinity, n to the power of 2n divided by 1 plus n to the power of 3n. You see, there is an exponent n at the top and bottom. The numerator, n to the power of 2n, n is in the exponent. Denominator, 1 plus n to the power of 3n, so n is in the exponent. Therefore, the root test is the most appropriate test. So An is equal to n to the power of 2n divided by 1 plus n to the power of 3n. So An to the power of 1 over n, you raise to the 1 over n means you divide each exponent by n. So when you divide the numerator exponent by n, you get n squared divided by 1 plus n, the whole cubed. And that is n squared divided by 1 plus n, the whole square, times 1 plus n. And that is, you divide numerator and denominator by n squared. So that is 1 over n plus 1, the whole square, times 1 plus n. When n is infinity, you get 1 over infinity. So limit n approaches infinity, An to the power of 1 over n is limit n approaches infinity, 1 over 1 over n plus 1 the whole square times 1 over n. When n is infinity, this is 1 over infinity, which is 0. So it is less than 1. Therefore, the series is convergent. Number 8. Sigma n varies from 1 to infinity, -1 to the power of n minus 1, n to the power of 4 divided by 4 to the power of n. So an, we are going to apply the ratio test. An is equal to -1 to the power of n minus 1, n to the power of 4 divided by 4 to the power of n. You find an plus 1 by replacing n by n plus 1. In the place of n, you write n plus 1. So this becomes -1 to the power of n plus 1 minus 1, which is n. Then n plus 1 to the power of 4 divided by 4 to the power of n plus 1. Replace n by n plus 1. Now find the ratio. An plus 1 over n is -1 to the power of n. N plus 1 to the power of 4 divided by 4 to the power of n plus 1 divided by -1 to the power of n minus 1, n to the power of 4 divided by 4 to the power of n. That is -1 to the power of n divided by 4 to the power of n plus 1 times n plus 1 to the 4 multiplied by the reciprocal. That is -1 to the power of n minus 1, 4 to the n divided by n to the 4. So the answer is -1/4 times n plus 1 over n whole to the power of 4, because 4 to the n plus 1 and 4 to the n cancels, leaving a 4 in the denominator. N plus 1 to the 4 over n to the 4 is n plus 1 over n to the power of 4. That is -1/4 times 1 plus 1 over n over n plus 1 over n. That is 1 plus 1 over n whole to the power of 4. Now you find the limit of the absolute value of n plus 1 over n. You may discard that negative sign because we are finding the absolute value. Limit n approaches infinity, 1/4 times 1 plus 1 over n to the power of 4. N is infinity, so it is 1 over n is 0. So 1/4 times 1, 1/4, which is less than 1. So the limit is less positive and less than 1. And therefore, the series is absolutely convergent. So it is convergent because in the absence of -1 to the power of n minus 1, it is convergent. That is, sigma bn is convergent. And therefore, sigma an is absolutely convergent. We may use the alternating series test also here. That's not very difficult. Number 10. Sigma n varies from 1 to infinity, n square e to the negative n cubed. So let fx is equal to x square e to the negative x cubed. We are trying to apply the integral test. So f prime x is equal to x square e to the negative x cubed times minus 3x square plus e to the negative x cubed times 2x, product rule. Pull out the common factor. I am pulling out a negative sign also. Negative x e to the negative x cubed times 3x square minus 2. X is pulled out. This is less than 0 when 3x square minus 2 is positive. 3x cubed minus 2 is positive, means x cubed is greater than 2/3. That is, x is greater than cube root of 2/3, which is less than 1. And so, for all values of x, it is a decreasing series. So fx is a decreasing function, so we may apply the integral test. Integral 1 to infinity x square e to the negative x cubed dx is equal to integral x varies from 1 to infinity e to the u negative du over 3, where u is equal to negative x cubed. U is equal to negative x cubed. So du is equal to minus 3x squared dx. X squared dx is minus du over 3. So that is negative 1/3 is pulled out. E to the u, and the derivative of e to the u is e to the u. X varies from 1 to infinity, and u is negative x cubed. So negative 1/3 times e to the negative x cubed. X varies from 1 to infinity. That is negative 1/3 times e to the negative infinity minus e to the negative 1. 1 cubed is 1. That is 1/3 times e to the negative infinity is 0. So 2 negatives makes a positive. So 1/3 times e to the negative 1, that is 1 over 3e, which is finite. And therefore, sigma finite means that integral is convergent. Therefore, sigma n varies from 1 to infinity, n square e to the minus n cubed is convergent. This is the integral test. Integral 1 to infinity x square e to the negative x cubed is convergent because the answer is a finite number, and therefore the series is convergent. Number 12. Sigma n k varies from 1 to infinity. K 1 over k times square root of k square plus 1. The 1 over k times square root of k square plus 1 is less than 1 over k times k square y, because k square plus 1 is more than k square. So denominator of the left side is greater than the denominator of the right side. So the whole expression is less than, 1 over 3 is less than 1 over 2 because 3 is greater than 2. Just like that, this is less than 1 over k times square root of k square. And therefore, this square root of k square is k times k is k square. So this is sigma 1 over k times square root of k square plus 1 is less than 1 over sigma 1 over k square. The right side converges because of the t-test. Therefore, the left side converges. So this is the comparison test. Number 14. Sigma n varies from 1 to infinity sine 2n divided by 1 plus 2 to the power of n. So an is sine 2n divided by 1 plus 2 to the power of n. We know sine theta is always less than or equal to 1. Therefore, sine 2n is less than or equal to 1. So sine 2n divided by 1 plus 2 to the power of n is less than or equal to 1 divided by 1 plus 2 to the power of n. You divide both sides by 1 plus 2 to the power of n, and that is less than 1 over 2 to the power of n, because the denominator of the second one is greater than the denominator of the third term. Therefore, sigma 1 to infinity sine 2n divided by 1 plus 2 to the power of n is less than sigma 1 to infinity 1 over 2 to the power of n. Right side is a geometric series with r is equal to 1/2. Therefore, the right side is convergent because r lies between negative 1 and positive 1. R lies between negative 1 and positive 1. So that is convergent, and therefore right side converges. Therefore, the left side also converges. Number 16. Sigma n varies from 1 to infinity square root of n to the 4 plus 1 over n cubed plus n. So an is equal to square root of n to the 4 plus 1 over n cubed plus n. Discarding the non-dominating terms, you get Pn is equal to square root of n to the 4 divided by n cubed. That is n square over n cubed, which is 1 over n. So this is your Bn, and you're going to use the limit comparison test. sigma Bn is 1, sigma 1 over n, which diverges, that is the p-test. And now let us find an over Bn. An over Bn is equal to square root of n to the 4 plus n divided by n cubed plus n divided by 1 over n. That means multiplied by n over 1. And you factor out n to the 4 from the numerator and n cubed from the denominator. So you get n square, square root of n to the 4 is n square times square root of 1 plus 1 over n cubed divided by n cubed times 1 plus 1 over n square multiplied by n. There is an n here. So numerator n square times n is n cubed. That cancels with the denominator n cubed. So it simplifies to square root of 1 plus 1 over n cubed divided by 1 plus 1 over n square. Therefore, limit n approaches infinity, an over bn is equal to limit n approaches infinity, square root of 1 plus 1 over n cubed divided by 1 plus 1 over n square, which is square root of 1 plus 0, which is 1 divided by 1. So that limit of an over bn is equal to 1, which is finite, and also sigma bn diverges. Therefore, sigma an also is divergent. Sigma bn diverges because of the p-test. So sigma an also is divergent. Number 18. Sigma 2 to infinity, because n cannot be equal to 1. If n is 1, denominator becomes 0. So sigma 2 to infinity, negative 1 to the power of n minus 1 over square root of n minus 1. So bn is 1 over square root of n minus 1, and limit n approaches infinity, bn is 1 over infinity, that is 0. So the limit is 0. Now bn plus 1 is, you replace n by n plus 1, you get 1 over square root of n plus 1 minus 1. And bn plus 1 is less than bn, because the denominator of the left side is more than the denominator of the right side. You have n plus 1 here. And by alternating series test, sigma n is convergent. So bn is a decreasing sequence, and the limit n approaches infinity, bn is 0. So by alternating series test, it is convergent. Okay, so number 20. Sigma n varies from 1 to infinity. Cube root of k, k varies from 1 to infinity. Cube root of k minus 1 divided by k times square root of k plus 1. So ak is equal to cube root of k minus 1 divided by k times square root of k plus 1. You discard the non-dominating terms from the denominator and the numerator. We get bk is equal to cube root of k divided by k times square root of k. That is k to the power of 1/3 divided by k to the power of 3/2. 1 plus 1/2. That is 1 divided by k to the power of 3/2 minus 1/3. That is equal to 1 divided by k to the power of 7 over 6. 3/2 minus 1/3 is 7 over 6. 3/2. 3 over 2 minus 1 over 3. And that is this fraction. Go to math, fraction 7 over 6. So bk is equal to 1 over k to the power of 7 over 6. Therefore, that sigma bk is convergent because of the p-test. Sigma n k varies from 1 to infinity. Bk is convergent because of the ratio test, p test. So AK divided by BK is k to the power of 1/3 minus 1 divided by k to the power of 3/2 minus, this is a plus k. So denominator, this is a plus k, and here also it is a so this is AK divided by BK. So this must be a plus times k to the power of 7/6 over 1. Distribute k to the power of 7/6. You get k to the power of 3/2, 1/3 plus 7/6. That is 3/2 minus k to the power of 7/6 divided by k to the 3/2 minus k. Divide both sides by k to the power of 3/2. You get 1 minus 1 over k to the power of 1/3 divided by 1 minus 1 over k to the power of 1/2, 1 minus 3/2, that is 1/2. So the limit k approaches infinity, AK over BK is 1 minus 0 over 1 plus 0. The denominator is a plus. So that is 1 minus 0 over 1 plus 0, which is finite, and the sigma BK converges. Therefore, sigma AK converges. Number 22. Sigma k varies from 1 to infinity, 1 over 2 plus sine k. AK is equal to 1 over 2 plus sine k. We know negative 1 less than or equal to sine k less than or equal to 1. You add a 2 on both sides. So you get negative 1 plus 2. That is 1 less than or equal to 2 plus sine k less than or equal to 3. Now find the reciprocal. So 1/3 less than or equal to 1 over 2 plus sine k less than or equal to 1. So this means AK lies between 1/3 and 1. AK lies between 1/3 and 1 means limit n approaches, k approaches infinity, AK also lies between 1/3 and 1. So limit is not equal to 0. If the limit is not equal to 0, then that sigma AK diverges. So limit of the kth term is not 0. That means it is divergent. Number 24. Sigma 1 to infinity, n varies from 1 to infinity, n times sine 1 over n. N is equal to n times sine 1 over n. So limit n approaches infinity, an is equal to limit n approaches infinity, n times sine 1 over n. Let 1 over n is equal to theta. So n is equal to 1 over theta. So this is equal to limit theta approaches 0, because as n approaches infinity, theta approaches 0. So this limit is limit theta approaches 0, 1 over theta times sine theta. This is 0 over 0. And so you may use the L'Hopital's rule, assuming that theta, this is a continuous function. So differentiate, derivative of sine theta is cos theta, derivative of theta is 1. Therefore, limit is cos 0. Cos 0 is 1, which is not equal to 0. Therefore, sigma n diverges. Limit must be 0. Limit of the nth term or the kth term must be equal to 0. This is not equal to 0. So sigma an diverges. Number 26. Sigma n varies from 1 to infinity, n square plus 1 divided by 5 to the power of n. So an is equal to n square plus 1 divided by 5 to the power of n. N plus 1 is equal to n plus 1 the whole square plus 1 divided by 5 to the power of n plus 1. We are going to apply the ratio test. So an plus 1 over an is equal to n plus 1 the whole square plus 1 divided by 5 to the power of n plus 1 divided by n square plus 1 divided by 5 to the power of n. That is equal to n plus 1 the whole square plus 1 divided by 5 times 5 to the n, that is 5 to the n plus 1, multiplied by 5 to the n divided by n square plus 1, 5 to the n cancels. That is 1/5 times n plus 1 the whole square is n square plus 2n plus 1 divided by n square plus 1, that is 1/5 times n square plus 2n plus 2 divided by n square plus 1, divide numerator and denominator by n square. So that is 1/5 times 1 plus 2 over n plus 2 over n square divided by 1 plus 1 over n square. And therefore, limit n approaches infinity, absolute value of n plus 1 over n is equal to limit n approaches infinity 1/5 times 1 plus 2 over n plus 2 over n square divided by 1 plus 1 over n square, that is 1/5 times 1 plus 0 divided by 1 plus 0 because n is infinity. So that is equal to 1/5, which is less than 1, and therefore sigma n converges. So that is a ratio test. If the limit of absolute value of n plus 1 over n is less than 1, it is convergent. Number 28. Limit n approaches, n varies from 1 to infinity. It's not limit. Sigma n varies from 1 to infinity e to the power of 1 over n square. So an is equal to e to the power of 1 over n square. Let bn is equal to 1 over n square. And an over bn is e to the 1 over n square divided by 1 over n square. N square cancels. That is e to the 1 over n. Therefore, limit n approaches infinity, an over bn is equal to limit n approaches infinity e to the 1 over n, which is e to the 1 over infinity, which is e to the 0. E to the 0 is 1. It is finite and not positive and finite. And so that limit is equal to 1. Since sigma bn converges, why sigma bn converges? Because of the p-test, p is 2 greater than 1. So since sigma bn converges, sigma an also converges. Number 34. Sigma n varies from 1 to infinity, 1 over n plus cos square n. We know cos square n is less than or equal to 1. That means cos square n lies between 0 and 1. You multiply both sides by n, you get n times cos square n is less than or equal to n. You just discard the first part. Cos square n is less than or equal to 1. Multiply by n. N times cos square n is less than or equal to n. You add n on both sides. You get n plus n. Cos square n is less than or equal to n plus n. That is n plus n cos square n is less than or equal to 2n. And therefore, find the reciprocal. So therefore, 1 over n plus cos square n is greater than or equal to 1 over 2n. 1 over 2n. And therefore, sigma 1 over n plus n cos square n is greater than or equal to sigma 1 over 2n, which is the same as 1/2 times sigma 1 over n, and the right side is divergent because of the p-test. Sigma 1 over n means p is equal to 1. So the left side is greater than or equal to a divergent series. This means right and left side also diverges. Okay, that was the end.